right. We're doing POTD. It is the 8th of April. Did I do yesterday's? I don't remember. Wait, hang on. Oh, I completely forgot to do yesterday's. Oh, no, wait, today's... No, I did. Okay, we're fine. Sorry. I was like, oh my god, I've lost my streak. I knew I'd lost my streak before when I took some time off. I mean, not time off. I didn't do it for a couple of days because I was preoccupied. But yeah, okay, so we're fine. Streak is still on, which is great to see. Let me get rid of... Oh yeah, I need to figure this out. I don't want to delete you, so let's do that. Okay. Oh, XOR. Oh no, I hate range queries. Oh wait, I already clicked it. Sorry, I thought it wasn't. I clicked it like 74 times without realizing. Where's my glove? Not that it really matters, but it'd be nice. Oh, there it is. Okay. XOR after range multiplication queries. Please don't be a segmentary. Please don't be a segmentary. You are given an integer array, nums, of length n, and a 2D integer array, queries, of size q, where queries I... queries I is left, right, k, and v. For each query, you must apply the following operations in order. Set idx equals to L, left. While it's less than or equal to R, right, update nums at idx equals nums at idx times the value v. So you're basically so this is like the value you're multiplying with. And set idx, so you increment id. It's like an increment. Okay, so left, right, increment, and the value to multiply by. Return the bitwise XOR of all elements after processing all the queries. Okay, so this can be a bit tricky. Oh, okay, nums is only 1,000 elements, which is not too big. As is queries, the value of nums can be quite large, but the actual... So they might allow an n-squared solution, or an n by q solution, which is not always the case. Sometimes they try and make you be like, you have like a log in there. But in this case, you might get away with... So it's POTD 3653. And then... Oh, wait, normally I write that the other way around, don't I? Whatever. So you're given nums. So just to clarify, input, you've got nums, which is an integer array. So it's going to look something like, block of memory with some values in there. 3, 2, 1, 6, 5. Oh, can there be negatives? Probably, right? Oh no, there can't be. Okay, 7. And then a query. It's also... it's a 2D array. So you're going to have an array. And within each array, you're going to have the element of each array is going to be an array. And so on. Where each element... How many things are there? 4? Yeah. Left, right, k, increment, and the value. So we're taking each one of these red blocks, and we're going to have to start from L, go up to index R with an increment of k, and for each value we hit, we should multiply it by v, and also remember to mod it. So for I in the range, L up to R, we'll just say +1 because for Python it's exclusive. Incrementing by k, nums at I times equals v, like the corresponding v value, but modded as well, don't I? Hang on. So this thing is equal to nums, the original nums at I, multiplied by the v value, whole thing modded with the mod, 10 to the 9 plus 7. So because we're going with Python, I'm not going to be too concerned about the integer overflow stuff. it's probably a good thing to practice thinking about that stuff. But for now, I feel like the issue is more about doing these queries efficiently. So naturally, what's happening is we are trying to recognize, I suppose, we're trying to handle these queries quickly, because essentially, let's say we have, all these queries. Oh no, you can brute force it, yeah, because the worst case query is if it goes from 0 up to n minus 1, where n is equal to the length of nums. In the worst case, a query goes like this, increments by 1, and has a value of v, in which case you have to iterate through the entire array once, doing the multiplication, like multiply by v, doing the mod as well, and then you have to do that q number of times, one for each query. So the worst case, so brute force approach will be O of n by q, and by our constraints, we have 1,000 by 1,000, which is like, O of 10 to the 6 or whatever. Or I shouldn't say O of, like, it's roughly the order of 1,000,000, which by LeetCode standards will work generally. It's just that it will be slow. It will be one of the slower things. I'm imagining that's why the acceptance rate is so high, because people would have started by doing the brute force approach. So I will do that as well. So simply put, for Q, no, I'll for L, R, K, and V in queries, for I in range L up to R plus 1, increment by K, nums at I is equal to nums at I multiplied by V, whole thing modded by mod, where mod is equal to 10 to the power of 9 plus 7. Yeah, and then answer is equal to nums at 0, and then for num in nums from 1 onwards, index 1 onwards, answer equals answer, I can say XOR equals num. Turn answer. Do I back the brute force? I did have a pretty bad day. Yes. Oh, I remember what happened yesterday. Yeah, I must have blocked it out. It was that. Wait. Was that yesterday? When I failed 3 times and I should have only failed once because I was being stupid for half the time. It was the robot thing, right? When you walk. Oh, there's no robots. Anyway. So you have a 1D array. Should really make these numbers a bit bigger. Okay, and then you have a 2D array, so it's like index 3, 4 up to 6. Wait. I can't go backwards. No. Alright, let's try that. If that works, I'm pretty confident. Like, it's brute force. It's not like not trying to be too clever. All right, I respect it. Cool. Oh wow, I'm surprised. Okay, my understanding is because the constraints allowed it, people kind of followed this kind of curve. I would assume that even these guys, similar, yeah. So brute force, right? Fair enough. This is literally what I did. Except this guy did this. I don't know what that does, other than I think it's just for typing. Yeah. I guess this wasn't always a thing. That's interesting. Anyway, so fine. We have it done. and that means my acceptance rate is safe. Hallelujah, right? Now let's try be a bit cleverer, right? Because I think you can be. And I imagine that I wouldn't be surprised. Is this a part 1? Yeah, so if this is version 1 of the problem, often probably the next day, tomorrow, for the problem of the day, they'll do version 2. And it'll be a hard problem instead of a medium in this case. And the reason it'll be hard is because this will be 10 to the 5 and this will be 10 to the 5. So doing an O of NQ times solution, O of NQ times solution will not be acceptable. Now, of course, I can wait for tomorrow. However, I know in my heart of hearts, I probably won't have a lot of time tomorrow just because I've got some stuff due. So while I do have a chunk of time now, I can try and imagine that the O of NQ solution will fail. And with the safety of having got an accepted solution already, I can sort of experiment to my heart's content. All right, so I know I've done these kind of questions in the past. It has been a minute though. This idea of like having queries and like trying to sort of remember, I suppose, the progress of your queries so far across the different ranges. I've definitely seen techniques, but it's been a minute since I've done these particular types of questions, so I don't really remember them as much as I should. Let's take an example, because I think that will make my life a little bit easier. This is only one query. Let me do one with 2 queries. Maybe this one's good. All right, so we got nums is equal to 2, 3, 1, 5, and 4. And you got queries, which of course is a 2D thingy, but I'll do it in red, each individual query. We've got 1, 4, 2, and 3. And we've got 0, 2, 1, and 2. So let's start by just processing the queries as we would in the brute force solution. So we initially, nums looks like this. 2, 3, 1, 5, 4. When we process the first query, first query looks like 1 to 4, 2 and 3, right? We focus on index 1, 0, 1, up to index 4, 0, 1, 2, 3, 4. And we are going to increment by 2, and we're going to multiply by 3 along the values that get hit. Oh, it's the increment that makes things weird. If it wasn't an increment, I think I'd have a bit of an easier time, because it'd be like, multiply by v from here, and then after this point, divide by v. That might not make any sense, but there's like a certain type of array where you kind of you can kind of figure out the net result on any particular number by keeping track of like at what points you were multiplying and what points you were dividing at the starts and ends of intervals. That might not make any sense. Anyway, so yeah, we start here. This is our L. So this should be black. So after the first query, this will stay as 2 because we're not touching index 0. Index 1 will get multiplied by 3, so that'll become 9, because it's k then v, right? Increment and then 9, and then we have to increment by 2, so we skip the 1 and we go up to the 5, and the 5 gets increased to 15. 1 stays the same, and then again 4 won't change because it's 1, 2. We jump off. So now nums looks like this, and then second query will look 0, 2, 1, 2, right? And so the nums in turn will transform into, so 0 to 2 with 1 and 2. So 0 is over here, 2 is over here. We're incrementing by 1, so we basically hit all of them. 4, 18, and 2. So doubling each of those, and then 15 stays the same. Oops, 15 stays the same, and 4 stays the same. Now, does that look about right? 4, 18, 2, 15, and 4. Cool. And then from there, naturally, you XOR everything. Means you have 4, XOR 18, XOR 2, XOR 15, XOR 4. And I'm assuming this goes to 0? If you XOR the same thing twice, surely everything goes to 0, right? And 0 XOR 18 Oh, you can't really predict like that. 0 XOR 2, you got like 1, 0, XOR 0, 0, so it'll be 1, 0. Just 2, I guess. Okay, whatever, I'll cheat. What is it? 31. Okay, so you get 31. You line up the bits, you figure it out, right? Fantastic, happy days. So we know brute force will work. Is there a way that I can keep track across the two queries without too much work? Is there a way I can keep track of which elements, I guess, got hit with the multiplier, you know? If you get hit with this multiply, if you get hit with multiply by 3, but you don't get hit with the multiply by 3, and you don't also, and then you get hit by the multiply by 3 because it's increased by 2, right? Yeah, increment is 2. So how do I keep track of that? See, originally I think the general idea that you normally do in this situation is like you create an array. You create an array where like I think everything gets initialized to 1. 1, 2, 3, 4, 5. I think I need 6 elements. 2, 3, 4, 5, 6. I'll just erase the excess. From memory, everything gets increased. Everything gets set to 1 originally. I say from memory, I'm kind of half guessing anyway. And then the idea is, okay, if you're going to multiply, let's say the increment's always 1, right? Just so I don't have to deal with this increment thing. Normally what would happen is, okay, I'm incrementing from index 1 to 4. So I'm incrementing from index 1 to index 4. So then that's the same thing as like imagining I multiply this entire thing by 3. And then, you know, I got 1, 1, 1. And then I divide by 3. Maybe I have 2 arrays. Tell me what I multiply by, tell me what I divide by. So I divided by 1, divided by 1, divided by 1, divided by 1, divided by 1. And now I divided by 3. So multiply by, divide by. Right? And then what that means is if I was just to process this first query, if the numbers are originally looking like, you know, 2, 3, 1, 5, 4 from index 0, 1 to 4, then I would say, okay, what should I multiply 2 by the query? Well, I multiply by 1 and then I divide by 1. So I get 2. What should I multiply by from here? I should multiply by 3 and then divide by 1. And here it's like, okay, what should I multiply by? Well, I should multiply by 3 again and divide by 1. The reason why we say 3 is because even though obviously it lines up to the 1, we're taking like the cumulative product here. So the cumulative product at this point would be 3. And we can pre-process, after we've done all the queries, we can pre-process the cumulative sum. So the cumulative, product. Cumulative product at this point is 3. 1 times 3 times 1. And the cumulative product down here is 1. So we multiply by 3, divide by 1. Same instinct here. Multiply by 3, divide by 1. Multiply by 3, divide by 1. And then here, if we had another element, this is just to show how the divide by 3 works. If we had another element, and we ask, okay, you know, we have a 7 here, what should it be multiplied with? You should multiply by 3 right? Because the cumulative at this point is 3. And then you should divide by 3. That is, you should multiply by 1 because this guy never got affected by the query. And that's why we need, I guess, the multiplication array first to tell us, how the number should be increased by. But then on the flip side, we should also have the divide array beneath to tell us, okay, do we have to divide by something because a particular range ended. So therefore the multiply by 3 that got added should be sort of negated by the time we reach index 5 in this case. So that's what I would normally do. And that's for when you have sort of nice slabs of interval, like for sure that from here to here, I highlighted the wrong thing, sorry, from here to here is when you are, doing your particular query. And I believe if you were to re-update with the second query, it would still accurately reflect all the changes, basically. I believe. Yeah. Because what is it? 0 to 2? So 0 to 2 would say, multiply by 4. Wait, hold up. No, multiply by 2, sorry. So this would say 2. And then you have to divide by 2 after index 2. So you divide by 2 here. So, for example, index 1 would get multiplied by 6 because it had a 3 over here and then a 2 previously, right? Index 2 would also get multiplied by 6, I believe, because, yeah, that carries weight. Like, the 6 carries across here. But the index 3, because it doesn't get affected by the second query, it would be multiplied by 6 divided by the 2. So I'm pretty sure, from memory, I'm pretty sure that, this would really accurately reflect the changes across the queries. Now, why this does not work in this very particular question, oh, my memory ran out, is because, I need this other reason. The reason this doesn't work is because we have this idea of a query does not affect the entire range because of the increment value. So like this very first query was actually, it said 2 here, I think, right? So the numbers that get affected are index 1 and index 3. And index 5 didn't exist, but anyway, it wouldn't be affected, right? So the same idea doesn't work because, yeah, multiplying by 3 here, you need to immediately divide by 3. And then you multiply by here 3, and then you should immediately divide by 3. I might as well be using this as if it's like I might as well just do it brute force at that point, because I'm applying each to each element in the range. I'm applying some kind of operation. I'm doing something in each spot. So especially, I think the smaller the increment is, the worse it will be. Unless it's 1. If it's 1, that's fantastic. Then it's just the original idea. But if it's 2, then it's really annoying because I'd have to all these sort of partition segments. If I try to apply this idea again, I would have to, multiply by 3, divide by 3, multiply by 3, divide by 3, which is very annoying. So what is my other option? If, man, if I try to build a tree that but normally segment trees and stuff, they hold continuous, each node represents a contiguous block of the array as opposed to little chunks of it. Would I really be, if I had to do this query where I have to look at every second, kid and skip some of them, would it really be that efficient to have to go to each individual child and update them? I doubt it. Oh no. Tomorrow's gonna be rough. What else could I do? This guy gets colored in. I skip one. I can't just straight up say, I can't do the same trick because there's potentially too many updates I'd have to do in one query, which would end up making it O of NQ anyway. Can I still apply the idea? I can't tell if this is like completely wrong for this question or if it's just a matter of trying to modify it, you know? Like, it's so close to being correct if not for the increment thing in the question, not for the k value in the question. So what else could I do? Maybe... What if I inspect all the queries ahead of time without doing any kind of updates? And then I sort of... Nah, we're still kind of doing, of... It doesn't really do anything. I was thinking, like, if I figure out all the ranges ahead of time, then maybe I could, like, sort of try and figure out where they overlap and stuff and, like, try and be efficient in that way. But I feel like that's basically what I'm doing anyway, right? I don't know how to deal with non-contiguous blocks, non-contiguous intervals or something, non-contiguous queries. If I... Could it be is it a tree? Like... Issue is, I feel like I learned about segment trees. There was like one question, maybe on the problem of the day a while ago, that sort of demanded segment trees. And I was like, I don't know what a segment tree is. So I looked it up and I worked through it and it was pretty cool. But it has been a minute of that as well. 2, 3, 1, 5, 4. From memory, it's like you basically build a binary tree where each node represents a subarray that after splitting in half. That's my recollection. So this guy, for example, would split into 5, 4. And this guy would split into 2, 3. Oops, 2, 3 versus 1. And then 2, 3 would naturally split as well. 2 and 3. And this is really cool normally because, like, the idea is if you think about each node as an object, like you actually can associate like attributes. You can keep track, for example, of like what is the minimum. Min equals 2, min equals 3. Min equals 1. In the base case, when you have one element, then the min is just that value. Min equals 4. And then, using a sort of bottom-up approach, you can keep track of the minimum sort of by looking at the two kids. Like, what's the minimum of these two kids? Well, 4. So 4. What's the minimum of these two kids? 2. What's the minimum of these two kids? 1. What's the minimum of these two kids? 1. What's the minimum of these two kids? 1. So, like, you can kind of do min... you can do, like, min range queries kind of thing. Find the minimum quite quickly in, if you have it structured like this. And there's also ways to, like, let's say you only want to look at... I shouldn't have put 1 on... I should have put, like, 1 at the start and 2. Let me do that. 1 and 2... 1 and 2. Sorry, yes. 1 and 3. So there's ways to, like, let's say you only care about the subarray from 3 to, like, from here to here. There's ways of querying this thing so that you only check that. So, like, I think it's something like, I can't remember exactly. But it's something like, you go down the tree and you, like, ask, okay, what's the minimum between these two kids? and you say, wait, that guy shouldn't be counted or something because that is not part of the index, so you exclude him. So it will report back 3 instead of 1. It should say 1. And they should say 2. Yeah, like, I don't know. It's cool stuff, but I don't know if it's really. Again, I just feel like these guys normally are looking at contiguous blocks for a query. I don't know if it's worth my time in terms of trying to do this for queries that skip numbers. Like, if the query number is really big and there's only like 4 numbers I have to update, then that's not a big deal. It's not the query number, sorry, the k number, the increment number. If the increment number is really big, so then like the jumps are really big, I don't actually have to touch that many elements, then that's fine. But the issue is if the increment's really small, then how do I realize? My days. I have no idea. I'm assuming the hint in this will purely say do it brute force. Yeah. Divide and conquer? Divide and conquer is good. Okay, that's interesting. I am cheating a little bit. So simulation is brute force. Divide and conquer, you could try use that. Although this feels sort of divide and conquer already. So, not really sure how that will work. Other than maybe, no. How does this divide and conquer normally you're like not skipping stuff? Why are we skipping stuff? Okay, let's say you have a query like 2 up to 7 with an increment of 3. I'm gonna make this bigger. 9 with an increment of 3 and a value of 2, right? So you have your array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we'll say 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we know that the values that get affected are 2, then increment by 3, 5, increment by 3, and 8. And specifically, each of these values should be doubled. So these blocks. I mean, that's kind of coincidental. It really ended there, to be honest, because 9 was the upper limit. But For every element that I multiply 2, I have to also note down that right after I divide by 2, using that old idea, right? So do I have to floor? I'm trying to figure out like what the formula for how many elements there I will have to increment. I think it's actually this plus 1. Because what if you have like 2 up to 8 with an increment of 2? 4. 1, 2, 3, 4. Yeah. Oh wait, so it's just 2, 4, 6, 8. So it is just 8 divided by. So it's 8 divided by 2, just like that. So maybe it is ceiling of that. 2, 4. So yeah, the query is 2 to 8 with an increment of 2 and some value. Then you have 2, start at 2, divided by 4 tells you how many times this jump will fit. 1, 2, 3, 4, like the fourth guy. So there's 4, okay. And then for the 2, 9 example, with a V, 2, 1, 2, 3, wait, what was it? It was increment of 3, wasn't it? 1, 2, 3, 1, 2, 3. You have sort of 7 jumps that you could take, 7. But if you're going to do 3, if your jumps are going to be 3 big, then how many jumps are there? Well, then yeah, that's why you have to ceiling it. Okay, yeah, I see you. Okay, you have 2 full 3 size jumps and then like an extra jump at the end. So yeah, that's kind of your formula. So it's like your R minus. Oh wait, no, this is wrong. It should be 8 minus 2. So I should add 1 because there should be 4. So see, it is floor. Sorry, 8 minus 2 divided by 2, whole thing plus 1. Okay. R minus L divided by the increment, and I think you should increment by 1 at the end to like count the extra. I'm pretty sure this is right because like 2, 4, 6, 8 should give me 4 thingies. And then like, but this formula by itself would give me 6, regardless if I floor or ceiling. Okay, sorry, like this will give me 3, but divided by 2, which is, this will give me 6 divided by 2, which is 3, so I need to add 1 to get that, to count that final guy. And same vibes with 8 minus, or 9 minus 2 gives 7 divided by 2 gives 3. Is 2 and I should get 3. Yeah, okay. Pretty sure that's the formula. So if I know how many elements there are and I know when those elements sort of start, then let's say I can really quickly figure out the range of all the what? How do you do this clean? For each element, there is for each query, sorry, there is a left that you know is going to be updated. You increase by k, you get the next element that will also be updated. What if I sort the queries somehow? I mean, they did say divide and conquer, so I don't know if sorting is really helpful, but if I sort by left and then I sort by right, then like I know that the queries are sorted in terms of which ones affect the left first, right? Like those ones occur first. And I also keep I prioritize the smaller queries first. Yeah, I got no idea. All right, I'll think on it, and hopefully by tomorrow I'll get an idea.